Hi students, MCQ number 5. Wires A and B have identical lengths and circular cross sections such that the radius of A is twice the radius of B. For a given temperature difference between the two ends, both wires conduct heat at the same rate. The relation between their thermal conductivities has to be given. So very direct question. All informations are packed here. So two wires are given. So one wire is A and the other wire is B. The radius of the thicker wire is RA and the thin wire is RB. And both are having the same length. So I can write LA, length of wire A is equal to length of wire B. And the radius of wire A is twice the radius of the wire B. It is given like this. Now for a given temperature difference is the same. So delta T, the change in temperature for A is equal to delta T for the wire B. Okay. Now what is the relationship between their thermal conductivities? So the rate of flow of heat, that is delta Q divided by delta T. This is the same for both the wires. It is the same. So both the wires conduct heat at the same rate. So this is for the wire A must be equal to delta Q divided by delta T for the wire B. So the quantity of heat flowing per second is represented by delta Q by delta T. This is only called as rate of flow of heat. For A and B, this rate of flow of heat is the same. Now, what is the expression for delta Q divided by delta T? So this is a thermal conductivity K into area of cross section of the wire pi r square into delta T divided by the length. So for the wire A, I will take Ka is the thermal conductivity and pi Ra square is the area of cross section of the wire and delta Ta is the rise in temperature and La is the length of the wire A, and this must be equal to the similar quantities on the right hand side. So thermal conductivity Kb into area of cross section pi Rb square into delta T for the wire B whole divided by its length Lb. Okay, now which are constants you see here? La is equal to Lb, is it not? So this La and Lb get cancelled. Then the rise in temperature delta T for both the wires. So delta T for A and for B, they are equal. So I cancel. Then this constant pi also get cancelled. Okay. So what are the remaining terms? Ka into Ra square. So Ka into Ra square is equal to Kb into Rb square. Okay. Now what is the relationship between radius of the wires? Ra is equal to twice Rb, is it not? So left hand side in place of Ra, I can substitute 2 Rb. So Ka into 2 Rb the whole square. So this is equal to Kb into Rb square. So 2 square is 4. So 4 into Ka, 4 Ka into Rb square is equal to Kb into Rb square. So now Rb square also can be cancelled. So Rb square is getting cancelled. So 4 Ka is equal to Kb, is it not? So 4 times Ka is equal to Kb. Therefore Ka is equal to Kb divided by 4. So we have got the answer. Ka is equal to 1/4 of kb. So that option D itself we are getting. Okay, so option D must be the correct answer. So Ka is equal to Kb by 4. So this is based on the definition of thermal conductivity. Okay, and we write an expression for the rate of flow of heat in terms of the thermal conductivity, and equating that rate of flow for A is equal to that of the B. We have solved and got Ka is 1/4 of a kb. I hope you must have understood well. Fine.